Now we will consider the method of using the quadratic formula to solve a quadratic equation. So when you cannot factor a quadratic equation and when you can't use factoring, you can use the quadratic formula. Now, you can always use the quadratic formula, but I like to try factoring first. So if factoring is not an option, then we can use the quadratic formula. So the first thing we need to do is write the equation in the form ax squared plus bx plus c equals 0. So for my equation, I need the constant to be on the left side to create a trinomial set equal to 0. So what I'm going to do is subtract 1 from both sides of my equation, which leaves me with 3x squared plus 6x minus 1 equals 0. Once I have my equation set equal to 0, then and only then can I identify my values of a, b, and c. So in this case, a is 3, b is 6, and c is negative 1. Those are the values I'm going to use in my quadratic formula. So I suggest we start by setting up the skeleton method. So we're going to do the opposite of b, or negative b. So I have my negative sign and then an open set of parentheses where I will insert the value of b, plus or minus the square root of b squared minus 4ac. So again, I've inserted empty parentheses everywhere. I will insert the value of a, b, or c. And then I'm going to divide by 2 times a. Now let's plug in our values. So b is 6. So I get negative 6 plus or minus the square root of 6 squared minus 4 times 3 times negative 1 all over 2 times 3. Now let's simplify. So x equals negative 6 plus or minus the square root of 36. Now, after 36, we have to be careful with our sign. Notice how I have 2 negative signs. I have one for the minus 4 and then one for the negative 1 from the c value. That's an even amount of negative signs. So if I were to multiply those 2 negative signs together, it would actually turn into a plus. So now in my square root, I have 36 plus 4 times 3 times 1, which is 12, all over 6. So since I had an even amount of negatives, 36 plus 12 is the expression that goes underneath my square root sign. So when I add 36 plus 12, now I have negative 6 plus or minus the square root 48 all over 6. So I have some more simplifying to do. In the margin, I'm going to really quickly simplify radical 48 because I do need to simplify that square root. 48 is 16 times 3, so I'm going to factor using a factor tree, and 16 is the perfect square of 4 times 4. So since I found a pair of numbers and 16 is a perfect square, I can simplify the square root of 48 and call it 4 rad 3. Then I'm going to take that 4 radical 3 and insert it back into my quadratic formula. So now I'm at the point where I have x equals negative 6 plus or minus 4 rad 3 all over 6. Now I have more simplifying to do. In the numerator, I'm going to factor out a GCF of 2. So I have 2 times the quantity negative 3 plus or minus 2 rad 3 all over 6. And the reason why I factored out a GCF of 2 is because the denominator 6 shares a common factor of 2. So I can simplify to basically 1/3. So now my final answer is x equals negative 3 plus or minus 2 rad 3 all over 3. And because of the plus or minus sign, that lets me know I have 2 solutions, but I can also write my solutions separate. X equals negative 3 plus 2 rad 3 over 3, or x equals negative 3 minus 2 rad 3 over 3, and those are my 2 solutions.